Good morning, students. Up to now, we have finished up to potential energy. Potential energy. This topic was finished from different notes, from not from NCERT book, and we get that potential energy U is equal to mgh. For what? For an object that is placed at a height from the surface of earth whose mass is m and g is acceleration due to gravity. So up to now we have finished that in mechanical energy there are various form of energy. In that form of energy, mechanical energy, the kinetic energy is given by k is equal to half m v square for an object whose mass is m and who is moving with v velocity, and potential energy is equal to m g h for an object of mass m and that is placed at a height h. So these two formula up to now we have. So now one topic is there in your book 12.1, 11.2.5 are the various energy forms are interconvertible. So yes, the answer is yes, means we can convert one form of energy to another form of energy. For example, suppose we have this windmill. In windmill we are converting the kinetic energy of air to the electric energy. By using motor we are converting electrical energy to mechanical energy. By using electric generator we are converting this mechanical energy to electric energy, because mechanical work we are doing to rotate the generator and from generator we are getting electricity. And there are various examples to explain that how we are converting one type of energy to another type of energy. So today one very important law is there, that is known as law of conservation of energy, that is given here. So what is this law of conservation of energy? According to this law, the total energy of an isolated system will remain conserved. So this law, actually this total paragraph no need to write from here, this you cannot write, this is so much because you cannot memorize it. So what you will write? You will write only this. Here it is given that according to this law, the energy can only be converted from one form to another. It can neither be created nor be destroyed. The total energy before and after transformation remains same. This is the law of conservation of energy. So what you will write? You will write these 4 lines. What is this? According to law of conservation of energy, or you can say according to this law, energy can only be converted from one form to another. It can neither be created nor be destroyed. The total energy before and after the transformation remains same. These 4 lines you will write. So because the question is there that we cannot create energy and we cannot destroy energy. Suppose you are burning something, it doesn't mean that you are destroying that mass, because mass is also one type of energy. You are not destroying, because you are emitting that mass is emitting same amount of energy in the form of heat, in the form of light, sound. So energy is converting to other form, we are not destroying it. Mathematically, in mechanical energy only, kinetic energy plus potential energy is equal to constant. After writing these 2-3 lines from here, you will write potential energy, this plus kinetic energy is equal to constant, means mgh plus half mv square is equal to constant. So up to here it is finished. It means for a moving body, if its potential energy is increasing, its kinetic energy will decrease. If kinetic energy is increasing, potential energy will decrease. For that, we have one question here, maybe here, let's see. Okay, it is in maybe in 11th. So now after this law, one task I am giving to you, one activity is given here in your book. An object of mass 20 kg is dropped from height 4 meter. Fill in the blanks with the following table by computing the potential energy and kinetic energy in each case. So what you will do, see here. So this is given. What you will do, height is given. You will calculate by using this height, this height, this height and this height, and this means 0 height. Okay, just above the ground means 0 height. You will calculate potential energy and kinetic energy, and then you will do the sum. But how you will do this? Because the object is of mass, see, this is the object of mass 20 kg is dropped from height 4 meter. So height is 4 meter from here to here. So it is dropped means here at this place initial velocity u is equal to 0. If u is 0, it means kinetic energy half mu square is also 0. Potential energy is m into g into 4 because h is 4. But when it will come to 3 height, second case, it will come to 3 height, the velocity will little bit increase. By which formula? We will use that formula, v square is equal to u square plus 2gh. That formula, how much is h? 1 meter only. When it will come to 2 meter, from that formula this height will become 2 meter. When it will come to this height, third 2 meter, means 1 meter, 2 meter, 3 meter and 4 meter. So at every height you calculate the velocity, you calculate by using that velocity, you calculate kinetic energy, and that kinetic energy you write here for first, second, third and fourth case and fifth case also. In the same way, at first height potential energy is equal to mgh 20 into g into 4. For second case it is 20 into g into 3. For third case it is 2. For fourth case it is 1, and for last case it is 0. So that is very simple, you write here. And kinetic energy you will write here. When you will do sum of this and this energy, you will see that total energy is same. That will be 20 into 10 into 4. So it will be 800 joule everywhere. Answer you will get this plus this is equal to, in each row will be 800. Okay, so this activity you try to do, and it will prove us that energy is conserved. So now I think this will be the last or second last topic of the chapter, rate of doing work. So this rate of doing work is what? Work upon time. Rate of doing work means work upon time. Actually rate of doing work is nothing but power. So power, what is power? Power is rate of doing work. Okay, so power is denoted by P, and the definition of power you can find here, what you have learnt. This definition you will write. Power is defined as the rate of doing work. Its SI unit is watt, and 1 watt is equal to 1 joule per second. So this is the definition you write from there. I am explaining what is power. Power is rate of doing work. If we are talking about rate, means rate of doing work means we will divide work with time. W upon T. Power is denoted by P and it is work upon time. Its unit, the unit of power is, unit of work means joule upon unit of time means second. Joule per second. This joule per second is known as, joule upon second is known as, joule upon second is known as watt. That watt is capital W, is denoted by capital W. Why capital W? Because it is on the name of scientist James Watt, and every unit that is on the name of any scientist is denoted with capital letter. So 1 joule upon 1 second is 1 watt. But there are some bigger unit also, like kilowatt. Kilo means 1000. So 1000 watt is equal to 1 kilowatt. So 1 kW we are writing in short form is equal to 1000 watt, means 1000 joule per second. So up to here only you finish today. Only this much for today. Thank you.